Well, I was just going to share a little bit about my current status. I start with sort of the end. Can you see my screen?
Yes, I can.
So I have an initial program that I'm trying to test the steering motor. Originally, I'm trying to get back to, let's stop this for a second. Was the previous steering software that I had that was ROS based. I'm just trying to pull it up here. Dun, 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 dun. Back to share. So this is one of the previous iterations of I would say a ROS based program that ultimately was, writing to the Citron motor controller, which provided steering control. And deep in here was, effectively taking command velocity data and translating that through this level of a PID into, creating that steer effort value and to either turn it left or right. The difference in the setup that I'm trying to implement at the moment is to not rely on ROS, and so also to use something that this simply had, I think, a KI value, and so I wanted to have, the full PID to help smooth out the steering. So I've now switched to the current software that I've got. And I know my limits using a 10-turn potentiometer. My full right is 350, my full left is 3500.
While you're right there, back up to where you just were. It says your actual thing says 3100 and 700, but it says it's really 3500 and 350. And then down about 4 lines, you say the range is 3500 minus 500. The 500 doesn't match anything there. Where did that come from?
Yeah, it's just me trying to limit this particular value was used when I was trying to calculate to use the potentiometer to create a PID and to use that range. It's me just trying to limit not trying to jam it full left or full right at the moment. So
Okay.
yeah, that could be 350 or 700. It's sloppy coding is what it is. And me trying to just limit the steering to a narrower range for the time.
I just wonder if you'd accidentally put the wrong number in, if you're just randomly changing that, I guess it doesn't matter what it is.
So at the moment I have potentiometers hooked up to get input for the PI and D, and another potentiometer to feed the target steering input. So my status at the moment is I've tuned this is old code, by the way, but I've tuned the PID to the point where the I and the D are both zeros. The P is at 5, and I've got a video out in Slack. I'm not sure if you can get to or not. I seem to be having trouble downloading it, but it'll turn left, it'll turn right, as you would expect. It wobbles, and I've got to. I think my next step is to finish tuning the PID. So that's where I'm at. And then Jeff sent this, which looks like a really good detailed write-up that I should go through, and maybe I'll throw out all the code that I've written and use his, but not sure yet. That's where I'm at.
I had some comments on what you're doing. First comment is your pot scaling. So you're reading up a pot that you're saying this is the requested position. So you read up the analog and you use a map function to immediately convert that into, I'll call them position counts. So you go from like 0 to 1023 or whatever the pot's putting out, you scale that directly to that 3500 to 500 or what you got. I would suggest you break that into 2 steps. The first step, read the pot, and then use a map function and convert that to an angle. So I don't know, just pick something like, say, plus and minus 45 degrees. And then the second step is convert to 45 degrees using your map function into your 3500 to 500. And the reason you want to do that is because once that's working, then at a point you can pull out the pot and just take the number that ROS is sending you, which is an angle, and stick that in there directly. Or you could take the number coming from your remote control, and if you scale it as an angle on your remote control, or just as it comes in, then that's also, you can also do that at an angle. So you can pick one of 3 different things, and they should all work. If that makes sense.
Well, I mean, I understand the words that you said. How to convert 0.495 to an angle. I'm not sure how to do that.
Well, just like several lines down where you're doing a map function, use your floating point map function and just say 0 to 45 and convert that into minus 45 to plus 45, just with a single map function. And then you'll have the number as an angle. So right now you're already doing that. In fact, right there, just 2 lines down, you're converting 0 to 4095 to your limits. Instead of putting the limits, just put angles in there.
I don't think I know. I mean, although I don't think I know the leftmost angle that it will steer or the rightmost angle that it will steer.
Well, at this point, I just pick something arbitrary and put in there, just so you've got an actual angle. Because, you know, as you say, once you go to do it, it's not gonna be right anyway, so you're gonna have to change it. So I would just pick, like, say, plus or minus 45 degrees, because I think yours will turn sharper than that. But and as far as the number coming from ROS, well, that's controlled by the parameters in ROS. So it's, you know, you can make that number. If you tell it it'll turn 90 degrees to the left, ROS will attempt to do that because it doesn't know what your vehicle will actually do. So it's just going to be some arbitrary number in between there. And then later, if you just say, well, it really can only turn plus and minus. Mine, I think, will only turn like plus and minus 30 degrees, my steering. And yours, it can turn a lot sharper, I believe. So I just picked the number plus or minus 45. It's a nice round number. And just for the moment, you know, just go with that. And then once you start playing around, if it turns out you can turn further than that, well, then make the numbers bigger and so forth.
And so you would have the steer target be an angle, not you know, a 4-digit integer number.
I would have it be an angle, and then the next step is you convert that angle into what you have right now. So just break that into two steps instead of doing it going directly from the pot to your encoder numbers. So you read the pot as an analog, convert it to an angle, and then convert the angle into the those encoder counts there, position counts. And that's just so you could just delete the part that says read the pot, and instead of that, just feed in a number directly from ROS, which is already going to be in an angle, or the number coming from your remote control. If you just scale that to an angle on the remote control, you just feed it in directly, or you could just feed across the raw number, and then in your receiver code, just say, okay, I'm going to scale that to an angle. But as long as they're all things as an angle, then you can interchange them at any time.
And it's in using this scenario is straight ahead 0.
Yeah, it depends. It depends how I would say if you're doing a mapping from 0 to 4095 and you convert directly, say minus 45 to 45, then I think that will be at least very close to 0 in the center and center steering. Now I realize your encoder numbers don't seem to be symmetrical for whatever reason. So I don't think you were accounting for that yet, were you?
No, I hadn't tried to. I mean, I think the physics of the lawnmower is that it will make a sharper left-hand turn than a right-hand turn. And therefore, I may be answering a different question than you asked or comment than you've made, but there are, well, I mean, in my program, I stated I haven't started to do the math. There's, you know, I mean, if I use the language of ticks, 1605 on the left and $15.45 on the right. So there's more ticks of steering on the left than there is on the right by about 100, which would be 8% or so.
And that's something else you can account for that later. But I would say if you're going from your pot to an angle, just scale it directly, and then the center of your pot will be 0 based on that. And then if you do need to account for any differences in your vehicle, that as you go from angle to your encoder counts, then that's where you could correct for it at that point. So that would correct for it for everybody, whether the numbers come from ROS or the pot or your remote. Yes, the center of all those will be 0, an angle of 0. And then as you convert the angle into your encoder counts, you could, if you need to do something funny there, you can. And you don't really have to change anything, for what you're doing right now, just for getting the motor to move, that is the most straightforward way to do it. And it did directly translate and it will work. But I'm just thinking ahead that if you want to swap that out, say, oh, I'm going to switch to ROS now, you could just, instead of calling the pot routine, call the ROS routine and take its angle and pass through everything, and everybody should be happy.
Okay. You said you had some other comments too, which I'm grateful for. What else did you know?
Let's see. I would say when you start out, I would say don't worry about the I and the D parameters. Just set both of those to 0. And since you have pots, I suppose you can just turn the pot down all the way to 0. But it should control with just proportional only. So if you just get the thing running and give it some proportional gain, and then turn the position and see if it tracks. If not, turn the gain up some more, and keep turning the gain up until it starts to vibrate a little bit and back it off. And then it should actually work and be drivable at that point. And if you decide that you take it out and drive it around, that's not working, then you can start playing with your I and your D. But if you're starting with the I and the D right now, I think it's just going to confuse you, and you're going to find out that it gets frustrating very quickly to get that to work. But it should actually work with just a proportional gain. So I just wanted to make that comment.
Okay. I
And
mean, it is.
I think on that video that I posted, the video or the video or the web page I posted, I think on the video, maybe under the sections, I think one of them said PID tuning. So he's going to take you through and tell you, with that little thing he built there on his desk, he's going to go through and change the numbers and show you how it works. So that would be good. If you go through that whole thing, that'd be a good thing to do that. Because he was also, I just randomly, I looked at it and he said, oh, well, here's how you figure out the end limits and all this kind of stuff. So he's got, quite a bit of stuff. He takes you through all the little steps you have to know. So that would be good to go through that.
I mean, with the P set at 5, it will steer and correct itself. So, I mean, it is functioning, as you said, with just the P gain.
And if you're using a P of 5, is that an integer number or a floating point number?
Yeah, that's interesting. I
Because I think
started
you
with
want,
integer.
I think you want
switched to
floating point on
float.
that. Because you might want 5.308 as a gain as opposed to 5 or 6. So that I do think you want that as a floating point number. So when you do the multiply, you do get the fractional stuff on there.
And that's what I wanted as well. For some, I'm sure it's my coding, or I did change to float, and I was getting really bizarre calculations, and I didn't take time to figure out why. And when I say bizarre, the steer effort, so the steer effort represents, how much voltage is going to go to the motor. And 5 integer, with this level of difference, was generating, as you can see, a very low steer effort. When I used floating point, a P of 0.9 was maxing out the steering effort on very low error. And I wasn't quite sure why it was doing that. And so rather than trying to figure that out, I just switched back to integer.
Well, especially if you have low numbers like 5, you definitely don't want an integer because your choices are 4 or 5 or 6, and you want all the range in between those numbers. So I think you're going to have to go to floating point. So I assume you're reading your pot, which is going to give you like 0 to 4095, and then you want to scale that into a floating point number somehow. And I somewhere in your code you said something like KP divided by 100 or divided by 1,000 or something. Is that might have been your old code you were looking at, but I do think you want to get to the point where you could turn your pot and then print out whatever that floating point KP is and watch it go from 0 up to whatever you've got it scaled to. Watch it go smoothly up and down, and then do that first so you've got actual numbers, because it seems odd. A 0.9 shouldn't, if you're simply multiplying your error by KP and you're multiplying by 0.9, that shouldn't give you bizarrely large numbers. So I don't know.
Yeah, in my code at the moment, I was mapping the potentiometer used to input the P between 0 and 20. Only because my guess was a pit of 8 was going to be where I needed to be, and so I just mapped it there.
So what I'd suggest is just fire up that thing called out. Are you printing that out anywhere right now? Whether you're not, make sure you print that out in your
Yes.
Well, that's not steer error. No, out is simply the translation of your pot
Oh,
to your floating point number.
yeah, it's this P number here.
So I would think if you're printing that out, then start up your Arduino IDE and say turn on the plotting function and plot that field. And as you turn your pot from 0 to maximum, you should be able to see that smoothly go, from here up to 20 and then back down to 0 again as you turn that. And if it's jumping or doing something stupid, then they'll give you an idea of either that map function's not working or whatever. So just read. In fact, just read the pot and make sure it's going from 0 to 4095 and smoothly. Again, if you watch it on your plotting function, as you turn it, you should be able to see that smoothly move up and down, and then look at it after the map function as that out variable, and see if that goes from 0 to 20 smoothly without jumping or doing anything funny. And at that point, if that's putting out a floating point number that goes 0 to 20, then it should work. So I don't know. Did you change something else at the time? KP pot. Because I'm thinking maybe you changed something else at the time. That other code you just had where it was loading KP, what did that say it was doing? Yeah, right there. What's that doing? So it says at the top, it says KP pot equals remap. What's remap doing?
That's making that analog read of 0 to 495 into 0 to 20.
Oh, that's that function we were looking at where you're reading the pot and doing the map function.
Mhm.
So then theoretically at that point, KP pot should go 0 to 20 as a floating point number. And then down here you said KP equals KP pot. What is KP defined as? Is that a float or is that a int or long or something else? And KP pot too. What are those two defined as? Depending on you might be able to put your cursor on the top of that. Somewhere on the screen it might pop up and tell you what that's defined as. Otherwise, you got to go back to the beginning where you defined it.
Float, KP is float.
And what about KP pot?
Long.
Well, that's a problem because you're taking a 0 to 20 as a floating point number and load it into a long, so you're going to get integer values that go 0 to 20. So KP pot's going to have to be a float also.
Yeah. So I'll work. Thanks for the suggestion. I'll work on getting P to be full float.
So at that point, if you as I said before, inside of that function, if you print out the out and watch it, it should go 0 to 20 as a floating point number. And now if you go look at KP pot, you're going to see that's going to step by one at a time because you converted the float into a long. So that's going to do goofy things there too. So that's something you could see as a debug step. If you plot that as it's running, you can watch it and see it do that.
Yeah. Any other words of wisdom?
Two more words of wisdom. I don't know which one to do first. I preferred to add an artificial end limit to my code. So somewhere in your code, you're going to generate this. You're going to come up with the thing that says steer effort. Where in your code do you use steer effort?
Well, here's where I clamp it.
Okay, plus and minus. Okay, what do you do down below then?
Well, this is where it actually.
Okay, so stop right there. What I would do is at this point, it says here's the number coming in. Do we want to go forward? Do we don't want to go backward? So somewhere in here, before you actually write this stuff out, I would say put in a line of code that says something like, if the steering position, and I'd use the numbers right off the pot or whatever. Say if you're beyond where you want to be, and the direction happens to be in that direction. So you've got the direction set right there, that dir pin. I think it's digital right. So somewhere there you said you clipped it and you said if tolerance pin set that right, steer right, steer left. What is that tolerance?
It's 50. So it.
I mean, what is it? What is it for?
Well, because if the desired position is it's to limit vacillating the motor when it's pretty darn close to where the target and the actual is pretty close. It lets the target and the actual be close, not exact.
Okay, I would say when you're all done, you want to remove that. You shouldn't have to. You shouldn't have to put in a trick to calm it down. So, but anyway, my point is here before you write out the actual PWM to the value, say, is my current encoder position beyond a certain direction left, and is the direction set to go left? And if it is, then just simply slam your effort to 0. So you want to just blatantly turn the motor off if you're trying to drive left and you're past a certain point. And then have another line of code that says if you're past a certain number on the right and direction says to go right, then slam the motor power to 0. And what that does, or can you stop sharing for a second and I'll pull up something here? Let's see, share screen. We'll see if this works. Actually, I should post the you can see my screen. The YouTube video is coming up.
I see a YouTube video circle black circling.
Okay, so here's the thing in operation. And if you go watch this right on YouTube, you can hear the sound. So you can hear the motor running while it's running. And one of these is I'm not sure why I got some stuff on the screen here. Let me get rid of this. But as I do it, one of the lines will be the pot. I've got a request pot, and I turn it to one direction, and it'll let me go further than what I wanted the motor to go. So I've got that stuck in there, and you'll see here. Let's just go ahead and run it and watch and see what it does. So you can see right here, the red is the request pot. So I turn the pot, and it comes up like this. But the motor comes over and says, "Oh, I hit my limit. This is my artificial limit that I put in." So it actually turns the motor power off completely at this point. And I'm thinking down here, I don't know why I've got 4 plots going on here. So anyway, if you try to go past that point, it just shuts the motor off. And you might think, well, I'll just set a limit on my steering and say if I'm within 500 counts of the hard stop, I'll just say, limit the incoming number so it can't go any farther than that. But it's still going to control. So what happens is, like in let's see, do I have an example here? If you're in the center and you say go out to this point on the right, it's going to go over there, but the thing's going to overshoot. It's going to oscillate back and forth. So it might, if it goes right up against a hard stop and you're still driving with full power, you're going to smash something. This should prevent it from doing that. So if it gets out past this arbitrary limit, regardless of whatever else is going on, it just simply kills the motor power. So it can't go in that direction. But if you try to back up, it can still back up because of the logic. And that just prevents you from smashing anything. So as I say, let me start this over and listen. Oh, yeah, you're not getting my audio, are you? So anyway, if you pull this up and listen, you'll hear, as you'll see this will come up here. It'll come along, hear this come up, and then you'll hear the motor stop right here. Then I turn the knob and see it comes back and catches up and starts following it. And then let me go a little further here. So right here, I'm just turning it slowly so it's following it. So here again, I went beyond the range, and the motor just simply stops. So it's again, I'm trying to think what this I thought was motor power. So I'm sending power out to the motor. Oh, that is what that is. So say if I'm right here at 0 and I say go in this direction, well then it says send this amount of the power of the motor, and the motor comes down here, and when it reaches the position, see the power drops to 0. If I say go the other direction, well, that gives it power in the other direction, and that's all working fine. And then out here, see, I went beyond the limit here. So it says put this much power to the motor, and it's still saying continue to go. So if that's up against the hard stop, it'd say, oh, apply full power against that hard stop until it smashes something. But right here, if you listen to it in the audio, you'll hear the motor turns off right here because it went past that point. So just a couple of lines of code will save you from slamming it into the hard stop or pushing against the hard stop with full power of the motor. So I think that's just something to add in, that is gonna protect things. And I can go look up the code. I have to figure out, it's on some Arduino IDE somewhere on one of my computers, but it's just a couple of lines of code. As I say, you use just write in your output routine, say, if I'm beyond this point going left and the direction says go left, then just kill the motor power. But in your case, just say write steer effort to 0. And then then you check for the other direction. If you happen to be over there and you go too far to the right, and it says we want to go right, then again, it kills the motor power. Otherwise, in between, it works just normally. And this also says, if it goes too far, it just kills the power of the motor, it stops, but it's recoverable because as soon as you move back, then it starts controlling again. So that's something, let's finish this off, see anything else here to see. And see, occasionally you can see I go beyond the limit and the motor just stops at that point. And down here, it did the same thing. So this is just an artificial number I put in, said, this is one limit, and this over here is the other limit. If it tries to go beyond that, it just kills the power of the motor. And in my case, I didn't have an actual hard stop. This just running on the table as bolted down to a board on my table. And in fact, let me back up. How do I do this? I had the other video that was, well, that didn't help. No, this one. So the other video is just the motor sitting on the table running. And that's this one. Play it. And if you're listening to the audio, you can hear it. When I go too far, you can hear the motor shuts off completely. And then when I move it slowly, it tracks, and the motor's whining because I haven't put in that other output routine. You can make the motor completely quiet if you use the I think it's called time 1 libraries as opposed to or timer 1 library as opposed to a regular analog write. And I don't remember what you're using there. So here, let me grab these and post this one. Let's see, how do I get chat? Oh, I lost everything. Let me stop sharing. Now I can get the chat. And I'll just, right now I'll just post them, then I'll fix it later. And what do they call it? Post editing? I'll do some post editing, and let me go back and get the other one of these. This one, can I just copy that? Copy link, copy link address. And we'll see if that works. Why does it say edit? Well, let me do it the hard way. Do it the old-fashioned way here. This one. Copy. And why that looks right. So those are the two videos. You can go watch those at your leisure to see what that's doing. Why do those look different? One of them says watch ? Something. I assume those are going to work. If not, I'll pull up the right ones and edit it in later. So let me put this somewhere. Am I sharing? I don't think so. So put this over here.
Second one worked.
So that's definitely a good thing to put in, because that way you don't accidentally say, oh shit, it went too far, and you're going to find out it went too far because you just broke something on the lawn tractor. So it's good to put that in, especially while you're experimenting. So if it goes farther than what you want, it just shuts the thing down. And I'll try to find that code later and post that. Okay, the next thing is, any more questions on that?
No, both of those YouTube links worked, by the way.
Okay. And this, as I said, this is just on top of everything. This is one of those tricks you can add, but this trick is something to protect everything. So when you're not paying attention, you don't end up driving it at full power, because those motors have a lot of power, and I don't know how much force your lawn tractor can take before it starts snapping things or stripping out your gears or whatever. So that's a good thing to put in there. Okay, so the other thing I had was, I didn't look at your new code. I was looking at your first code that you sent me privately. And I was noticing there you had like a timer that said you would check your millis and then say compare that to some amount, and then if it exceeds 20 milliseconds, then you wanted to run a motor loop. So that's how you're controlling the motor timing. Then you had another one that said after like 5 seconds worth of millis, you wanted to print out that line of text across there. Now keep in mind when you're doing print statements, that takes a finite amount of time to do that. So if you watch that, if you were to put something in the code, can you pull up that original code that you had sent me, or do I have to go find that?
This is the ROS code.
Let's go to the loop section.
I mean, steer base is where it was.
Well, it's under loop where you're checking your time. Okay, right there. So it says if millis minus previous timestamp steer is greater than steer interval, then you want to do something. Well, the numbers you put in there, I think you put a 50, which gives you 20 milliseconds. So you expect that to run every 20 milliseconds. Something you could do right there between line 186 and 187 is just say print. No. Oh, you'd have to, that line that says if millis minus previous timestamp steer is greater than steer interval, you have to separate that into 2 lines. So say make a temporary variable that says millis minus timestamp steer and make that called diff or something, say diff equals millis minus previous timestamp steer. And the next line say if diff is greater than or equal to steer interval, then do your steer base. And then when it decides that is true, instead of just calling steer base, also put a print statement that says print diff. So when you go to run this thing on your screen, you're going to see line showing. It's going to say 20, 20, 20, 20, 20, and then a big long line of text is going to come out. And then you want to look at that next number. If that next number is still 20, that means that the time it took to print that out did not affect your timing. And if it comes out 20, then it means it was able to output that whole thing and still get back to the next time slot 20 milliseconds later, and then everybody's happy. But if you print out that line, it comes back and says 100. That means it took a long time to print out that big long line of text, and that has screwed up your timing. And one thing you can do, is this on an Arduino or a Teensy or your ESP32 board?
ESP32.
Because the ESP32 is going to be an ARM processor, and I don't know how it talks to the USB port on that. Back on the original Arduinos, it had a Mega 328 Atmel processor, and that was connected by a serial port to the FTDI adapter chip. So you had an actual serial port in the link somewhere, and then when you go into your Arduino code and say set up open serial at 9600 baud, it's physically controlling that serial port on the board itself, and that's how fast it's going to output your characters. And you can set that quite high. You can probably, I always set mine like 115.2K baud, which is like 10 times faster than if you set it at 9600 baud. And if it's 10 times faster, it'll take 1/10 the amount of time to output that whole line of text. So by running that, if you have a physical serial port in the loop somewhere, that will limit how fast you can put that data out. And then what happens beyond that, say even on the original Arduino, so you had the Mega 328 is connected by serial port to the FTDI chip running at some baud rate. And once it gets to that chip, it then turns into USB world, and now it sends out packets at 12 megabits per second back to the computer. So that part of it is very fast, and it sends it out. And I don't know how it organizes the packets or anything, but in general, that's a very fast interface. But on a regular Arduino, you're going to have a problem if you're putting out a big long line of text like that. You want to put it out as fast as possible so it doesn't waste any more time that's necessary. Now on a Teensy or the ESP32, they may have a USB port coming directly out of the processor chip. So you might not have any actual UART serial data in between your print statement and your IDE on your Arduino, in which case it may work just fine. You might be able to put out anything you want and it's going to be, everything will be fast enough that it doesn't care. But if there is a physical serial port in between there, that may cause problems for you. But I think if you go in there, say that line 186, separate that out and say difference equals the subtraction of those two. And the next line say, if the difference is greater than stereo interval, then print the difference and then do your steer base. And that way, as it runs, you'll see you can, without putting an oscilloscope on, that will tell you real quick if that's a problem or not. So I'll stop and say, does any of that make any sense that I just said?
Well, it certainly makes sense. I mean, the question that I have is, I mean, at the moment, I'm trying to, let's just call it a non-ROS steer control, trying to tune my PID, and will printing these informational statements screw up my PID tuning? Because once I get the PID tuned, I'm going to strip all of that print stuff out.
The answer is it might. And that's why, as I say, if you put in that, just print out the difference each time through the loop there, that will tell you whether or not it's affecting it.
Okay.
And if it is affecting it, another thing you do is you can cut down the amount of stuff you're printing out. You don't have to have, a label in front. You don't have to say P colon and then a number and then something else, say out and then a number. You could strip all the labels off and cut that almost in half, the amount of stuff that's coming out. And you don't have to, you may not need all of that information at any given time. So you might be able to trim it down to like 3 different values and still have it be usable. But that's just something to check and see. And the reason why that's a problem is because if you're writing, say, a word processor or a spreadsheet or something, you're not worried about real-time control. So if you're doing a word processor, if I say cut and paste this, you don't care how long it takes. You just have to make sure the operator, the user, doesn't get annoyed because it takes too long. But if you've got something that has to happen every 20 milliseconds, then you have to be careful about putting in something that's going to use more than 20 milliseconds in between those times. So that's why when you start doing real-time control like this, it becomes a little more important what you're doing there. But even though you're putting in print statements, they might come back to bite you, was my point on that.
Yeah, that's a good feedback. I mean, I do have the baud at 115K, but that's of little consequence if it, given I've got a fair amount of printing stuff going on.
And as a test, as they say, you can put in that thing where you say each time it executes right by steer base, say print that difference value, and then run it, and then you can say then change your baud rate and set it down like 300 baud. So it's going to take forever to put out that line of stuff, and you should be able to see that number change if that's really a problem. But I don't know how the ESP32. There is few parts around those boards. It's hard to believe that it's got like an external FTDI adapter chip, but maybe they do. And I don't even know on the Teensy if that is directly out of the chip or not. Because if it's USB is connected directly to the chip, it could be you can get away with anything you want. You could output, the Gettysburg Address each time if you wanted to. With that, but it's a little more complicated because it passes the packets at 12 megabits per second from your board up to your computer, but it also breaks it into packets. So it gets data into a buffer. When it decides it has enough, it sends off a packet. And if not, then it might just sit there a while. So I don't know how that's going to affect the timing, but it's something to play with and see what you can make that do.
I'll make it.
And let's see, any other comments that I had? That's all I can think of at the moment, I guess. I'd gone through your old code a fair amount, and I thought we were going to comment on that, and then you popped up this new stuff that you just put in, so I haven't really looked at that at all.
Yeah, I guess I should post that to Guess just so you have the most up-to-date stuff.
You posted something, or have you changed it since then?
But
You posted it on Slack. I think you said, "Here's my code," if I'm not mistaken.
I did, but that still has I don't think that has the potentiometer, reading the potentiometer
Okay.
stuff. Anyway,
I didn't see it. Also put a reply on that. It says your PID is set at 5 and there's no KI, no KD. And I didn't, what's the other thing? Is that must be pointing to the code. But you definitely want to fix that so you're getting a floating point number coming off your position pot. That would be probably one of the first things you want to do.
that absolutely will be the first thing I do is figure out why.
And then add that thing about, limiting it at the end so you don't smash anything. That'd be a good thing to do. And let me, since I got a computer right in front of me, let's see, I got Arduino on here. Arduino, how do there's Arduino. Of course, I won't remember what it's called. It's probably called steering or something. So this may be a few left even looking for this, but as I say, I'll try to track it down later. And
yeah, I happen to be using the Visual Studio, so I have to learn as well how to plot variables with that.
If nothing else, just shut that down and then fire up Arduino and say, show me the plots, and that'll, just switch back and forth. It's going to be a pain, but you can do that. You might have to shut down Visual Studio completely so it's not using the connection, and then start up Arduino. I know on Arduino, I think if you just say disconnect, you can leave it running. But if you try to do anything as, oh, I can't talk, you might have more than one program trying to talk at the same time. Just as a hint.
Yeah, I definitely had that problem before when trying to have them both up and running.
Sketchbook. Recent. Here we go. Open recent. Blah, blah, blah. Rotation vector, quaternion. Well, it's either not on this computer or it doesn't jump out at me. So I'll have to go track that down. And it just turns out to be a couple lines of code that you have to add in. So it's definitely a good thing to have. Sketchbook. Blah, 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 blah. No, I don't see it on this computer, which means I have no idea where it is. Maybe it's on my Linux computer. or I lost it. I just whip up something. If I can think what your variables are called, I could just write up new lines and say, here, try this and see what it does. So other than that, I think last time I was mentioning that I found this. Let's see, let me get this off the screen so I can see what's going on here. Oh, I got too many screens and too many mouses here in front of me. So anyway, I said last time I bought this pipe at the hardware store. I cut off the end and I was able to put a bearing into it. So I figured if I cut off a piece about this long and put a bearing in the bottom and weld a bolt on the side like this to make my steering that turned, so the whole thing turns like this. I thought I could do it that way. But then I was watching that video. I said, I think it was on Amazon. I found those big robots that you can buy, like academic robots for like, they were what, $1,000 or maybe even more than that. I noticed one of them seemed to have the front end, instead of having the type of thing like you'd see, this type of thing like you'd see on a go-kart, they seem to have what looked like a big aluminum block as their steering mechanism. So they had something that looked kind of like this, that was just, like a big chunk of aluminum, and they had then an axle screwed into the end of it like this, and they had that hole down through the top where you would have say like bearings like that. So I put a bearing in the top and then put a bearing in the bottom. Yeah, instead of having to weld all the stuff, I could take this block of plastic and it can pivot around this point like this. And then if I got the bolt stuck in like that with the wheel on it, and my wheel turns like that. So I was going to try to do that. I'm going to have to drill and tap this piece of plastic, and this one's actually small enough. I don't know if I could tap that and make it stay in there. So I went over to the surplus store and I found this block of plastic. So it's, see here, see it's wide enough that I think I can drill a hole and tap it, and that shouldn't be a problem. And then
What a surplus store.
What about it?
I said, what a surplus store that you can just find a big block of acrylic or whatever it is.
And then here's a big block, a bigger block that I wanted, one that was more this shape as opposed to long and skinny like this. And this is the only piece I found that was like this, but it's big enough. If I want to do the 5/8 inch bolt like I had on the mini tractor, this should be big enough I can drill and tap that and make it work. So I should be able to scale this up and down. If I want to put bigger wheels on, I can use this, and again drill a hole here so it pivots like that. And then I could do the smaller one out of this kind of plastic. And if I wanted to, I could even take this kind of stuff and make a little one, put like a rollerblade wheel out here. So I'd probably cut it down a little bit here. But so anyway, I think you could scale that up and down to any size that you want. And another thing I found, I think I showed these wheels last time. These are from the same surplus store. And when I bought them the first time, they came with these bearings. And now they've got a big box of wheels with no bearings. So I thought, well, where would you find bearings? So after spending several hours on Amazon and eBay, it turns out these are wheelchair wheels. These are like caster wheels for a wheelchair. And the outside diameter on this bearing is 29/32 is the diameter of it. And this one happens to be 7/16 inch hole in it. So once you get those kind of things, then you can search and find them. And that's when they started to say, oh, they're for wheelchairs is where you get them. So this hole is 7/16, and you can buy the same bearing with a 5/16, which is slightly smaller. I thought there was a third size too, and I don't remember what it was, but anyway, I've got two of these wheels that have bearings, so I'm going to go ahead and use these. And I could take two of these without the bearings, and I've got some big motors that have a gearbox about this big, and the motor sticks out to about here, and they already have encoders on, so I can put two of those back to back, and I can use that to make back wheels, and then use these to make my steerable front wheels. So that's just more stuff I was playing around with and wasting time instead of doing anything I should be doing. So I still haven't decided, do I actually want to build yet another robot at this point? But yeah, I've been collecting parts and thinking about it, so that's what I've come up with.
Sounds like you're assembling the parts.
And I got a whole box of stuff down here, but eventually I'll say, what do I do with this? And I got to sort it all out, throw it in the appropriate boxes, and be done with that project, or go ahead and assemble it. So then also, I was thinking, well, if I make a smaller one, one of the other problems, the problems I have with the current one is it's a little bigger than I prefer, and it's way too heavy. And one reason it's too heavy because I've got a 35 amp hour lead acid battery in that weighs about 30 pounds. So I was looking at those batteries you're putting on your lawn tractor, and those look like they would be a lot lighter. So I might have to invest in some of those and then put, because I kept thinking, yeah, I'd like to go to modern batteries, but they're just so darn expensive. And then I looked at those ones you got. I think it was going to run me, I think for 4 batteries and shipping, it'd be like $55 or something that would cost me for that. And I can't remember what the lead acid batteries were, but it's probably not that much more expensive. And I don't know how well they'd hold up, but that might be another option on that too, because they're also much smaller. So they're not going to take up as much room inside of the thing. So they'd be lighter and smaller. And I have to figure out how to charge them without getting them to explode. So that's another whole mission that I don't know if I want to go down that at this point.
Yeah, I'm not an electrical engineer, but I'm jamming 14 volts into a 16 volt battery. I know it's the proper way, I think, to charge lithium ion phosphate batteries is a constant current until voltage is achieved. And I'm not, an alternator is not going to put out a constant current. It's going to, so I don't know. Time will tell whether it was a stupid idea or not.
And I think that the two problems you have with a battery like that is number one, if you overcharge it, it will start on fire and you cannot put the fire out. So that's one problem. But if you're undercharging it all the time, you may not have that problem. We'll see. We'll see how that goes. And the other problem is I was noticing on those specs, I think it says those batteries will put out 800 amps. So don't ever short those things out, because you're going to have a mess very quickly if you do.
Yeah, they definitely
So
will put out a bunch of
any
voltage.
wiring you have now between your battery and something else, you short that out, that wire is going to be gone if you put 800 amps through it.
So that's yeah, definitely good words of caution. So I am I am not, each cell is 4.2 max. I'm like at 3.8. I think was the math I did. So I definitely am going to be undercharging them.
And the other thing that occurred to me was you've got several cells in series. I don't know if they will automatically balance out, or if one of them will decide, one of them's going to decide to charge a lot more than the others, and it'll get hot, start on fire, or I don't know. I just haven't gone down the path of trying to figure those kind of batteries out.
Yeah, the issue for me was you could get a BMS to put on it, which would, try to protect all those things, but a BMS that will output, 180 amps or whatever it will take to start the darn thing, those are expensive BMSs. So you get a $30 battery and $180 BMS.
Yeah.
So, well, it's going to be one of those, we're going to do.
So is that battery still on your lawn tractor?
Mm-hmm.
I know you said you started it several times, the voltage went down a little bit. Have you taken it out, drove it around to see what it charges back up to? Or have you done that yet?
I have not driven around my tractor yet. That's once I get my steering organized, then I'll do that. But if I just let it sit without driving it, it takes the voltage up to 14.1, 14.2 volts. So as best I can tell, the alternator is configured to put out 14 point, let's just say 2 volts. And so that, divide that by 4, that means each of those cells is each of those cells is going to 3.5, 3.6. And they're rated for 4.2.
And the problem on mine is my lawn tractor is cheap enough. It does not have a voltage regulator on it. So it's going to put out whatever, based on how fast the engine's spinning, that's it. That's the voltage it's going to put out. So that'd be another.
Really?
I don't think I've seen anything in between there. It just simply has the alternator on there that goes through a diode. I think that ties right into the electrical system. So it, if the engine's running slow, it's not charging very hard. If it's running fast, it's charging harder. And I've never actually verified that, but there's very few extra components on the thing. So I don't see anything that looks like a voltage regulator or anything else like that. So I'm surprised it doesn't just fry the batteries, but if I put a battery in, I could run it for 2 or 3 years, and then usually it's because I leave it all winter and the battery goes bad because of that. But so it just amazes me that they got away with that, but apparently they did.
So a lead acid battery will let you jam 18 volts into it.
It will limit what you can put into it. If you put too high a voltage, it just stops. The voltage stops going up, and you're putting a lot of current into it at that point. Because you can take a standard 12-volt lead acid battery, and when you charge, you can charge it up to 15 volts, while you're charging it. And I don't know if it'll go any beyond that or not. If you charge it too hard, then it gets hot and it starts boiling the liquid out, and then it's no good if you lose all the liquid. So that's just another thing you have to worry about. But
well, I better than do a little bit more testing on with this thing because I don't I don't want a lithium a lipo battery blowing up on my tractor.
At the very least, you might want, if you keep it in the garage, you might want to not park it next to the wall or pile stuff on top of it just in case it decides to catch on fire. At least keep it out in the middle of the floor. And the other thing is you could just leave it outside in the yard, but then it's out in the yard, so that's a problem. I wouldn't be able to leave mine outside in the yard or somebody would take it, but in your neighborhood, you could probably get away with it.
Okay.
And you can get little panel meters that you just hook up the positive and the negative, and it'll tell you what the voltage is. So you could put, if you have some of those laying around, you could just mount one of them on there, tape it on or whatever, just so as soon as you turn your ignition switch on, it tells you what the voltage is. And when you start the engine, you can see what the voltage is and just watch it that way. Or if you have to, you could just pull out your DVM and hook up, and keep track of it like that as you drive it around and see what it's doing.
Yeah, what I don't know is what's the output of that alternator. Is it capped at all? Yeah, better figure that out.
Yeah, it's something that might tell you, by just watching as it drives around, you can see if it goes to some fixed voltage and stays there, or if it does go up and up and up or whatever. I assume it probably has an upper limit what I could put out in the first place, but I don't know if it does have a voltage regulator built into it somewhere. It probably takes whatever it puts out and converts that to some fixed voltage. But it would be if you've got a wiring diagram, see if it shows a voltage regulator on that. Have you seen like a physical module on there somewhere that you thought was a regulator, or you just assumed it had one?
When I took it apart, I wasn't looking, so I don't know. I mean, I can't say that I was even because I had the alternator off when I messed up my spark wires. So no, I don't know. I have to take the shroud off.
I guess the only thing you'd have to worry about is overcharging, because the lithium batteries don't want to be overcharged. So
Definitely not. Definitely not.
I guess that's all the words of wisdom I have on that.
Yeah, on that note, I think I'm done.
Okay.
You can turn off recording.